Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 11, Section 2. And in this video, we're going to be taking a look at the volume of cylinders and prisms. Both the volume of cylinders and prisms, both volume formulas are the same, and both volume formulas act in the same way. So what I will discuss with you in this video is why does that volume formula work? How does that get me the volume? In the previous video, we discussed that volume takes a 3D figure, and what volume actually tells you, for example, if you have a volume of 20 inches cubed, then that tells you that 20 1 by 1 by 1 inch cubes fit inside your object. So how does the volume determine this? How does it figure out how many cubes, 1 by 1 by 1 inch cubes or 1 by 1 by 1 centimeter cubes, whatever the measurement may be? How does it figure out how many cubes fit inside something? So the first thing we're going to do is we're going to take a look at the formula. The formula says that we need to multiply the area of the base, or big B, times little h, or in other words, the height. So we're going to take the area of the base times the height, and that will find you the volume for any cylinder and any prism. Okay, remember, prisms are defined by their base's shape. Prisms can have different shapes for their base. So you can have triangular prisms, you can have rectangular prisms, hexagonal prisms, pentagonal prisms, all kinds of different prisms. So first thing I'm going to show you is why does this work? Okay. When you find the area of the base, okay, what that is going to tell you, in this case, if I take a look at this rectangular prism that has a base with a 2 by 3 base, okay, so my base's area, as you can see here, is 6 inches squared, because I have 6 1 by 1 by 1, 6 1 by 1 inch squares. Or if you do the math, 2 times 3 will get you those 6 1 by 1 inch squares. So the area of my base is 6 inches squared. Now the reason why the area of the base is important is because that is going to tell you how many cubes, 1 by 1 by 1 inch cubes, are in the first layer of your shape. That tells you how many 1 by 1 by 1 inch cubes will fit into the first layer. Now, how many layers are in an object? The height determines how many layers there are. Okay? So in this case, my height is 3 inches. So that means I have 3 1-inch layers. Because remember, we're trying to split this shape into 1 by 1 by 1 inch cubes. So if I want 1 by 1 by 1 inch cubes, that means they have to have a height of 1 inch. So every 1 inch represents a layer of my figure. So I've got 6 cubes in the bottom layer. I've got 3 layers that are the same size as my first layer, right? If you take a look at that, the middle layer and the top layer are the same size as my bottom layer. So if I take the area of the base, which is 6, or in other words, the number of cubes in the bottom layer, and I multiply that by 3, which is how many layers I have in my figure, then I'm going to get the total number of cubes that make up the volume of my figure. I've got 6 cubes in the first layer, 6 cubes in the second layer, and 6 cubes in the top layer. So total, I have 18 cubes inside this rectangular prism. So by finding the area of the base, what I'm actually discovering is how many cubes are in each layer of my figure. Okay, that'll tell me how many cubes are in each layer, and then the height itself represents the number of layers. If you have a height of 5, you have 5 layers. If you have a height of 7, you have 7 layers. If you have a height of 8, you have 8 layers. Because again, my cubes are supposed to be 1 by 1 by 1. So if my height is 7, okay, and I want my cubes to each be 1 inch or 1 centimeter or 1 mile high, then that means I have 7 1-inch heights, or I have 7 1-inch heights, or whatever you want to however you want to, whatever unit of measurement you want to use. So I found the area of the base, which told me that there were 6 1x1 squares in the area of the base, and each of those squares belongs to a cube. So each of these faces, each of these squares here belongs to a cube in the base. So that tells me that there are 6 1x1 inch cubes in the base, and the height tells me the height of 3 tells me there are 3 layers that each have 6 cubes in them, and so 6 times 3 tells me there are 18 total cubes in this figure. And that will work whether or not you have a rectangular prism, triangular prism, a cylinder, a hectagonal prism. No matter what the shape of the base is, when you find the area of the base, that's telling you how many 1x1 squares you have in the base. So no matter what shape the base is, when you find the area of the base, okay, when you find the area of the base, no matter what the shape is, it's telling you how many 1x1 inch cubes are in the base. And the height will always tell you how many layers there are, no matter what the shape is, whether it's a cylinder, triangular prism, rectangular prism, hectagonal prism, octagonal prism. This works for all prisms and all cylinders. The only thing that's going to change about this formula is what you actually plug in for B. The height, you just plug in whatever the height is of the figure. If the height's 7, you're going to plug in 7. If the height's 8, you plug in 8. If the height's 10, you plug in 10. The only thing that changes here is what you plug in for the base, because if the base is a triangle, okay, so if the base is a triangle, then you would have 1/2 base times height times height. So I should actually make this a capital H. So we're going to make this a capital H. Capital H will represent the height of the prism. This lowercase h represents the height of my base. So this is the area formula for the triangular base. This is the height of the prism. So area of the base is right here. This is the area of my base, okay, for a triangular prism. Now, again, this B is going to change depending on the shape of the base. So that's with a triangle. If I had a cylinder, for example, a cylinder has a circular base. So instead of having 1/2 times base times height for the area of a triangle, I'll have pi r squared times big H. So area of the base again, okay, my base in a cylinder, a cylinder is basically a can. If you ever had a can of soup, okay, a can is a cylinder. So you find the area of the base, okay, which will tell you how many cubes fit into that circle, and then you multiply that by the height of the can or the cylinder, and that tells you, remember, the height represents the number of layers. And so let's say that we found the area of my circle to be 5 inches cubed. Okay, so in other words, 5 1x1 inch cubes fit inside this circle. That tells me that each layer of my figure has 5 cubes in it, or can fit 5 cubes in it. And if my height is, let's say my height was 5, or my height was 7, then I would have 7 layers of 5 cubes, and so I'd have a total of 35 inches cubed. So again, the big B will change depending on the shape of your base. Okay. Now, if we had a rectangular prism, okay, we would just have base times height of the rectangle on the rectangular base times height of the prism. And so that's really all there is to finding the volume of a cylinder and the volume of any prism. The one thing you're going to want to be aware of is what are your area formulas for these different shapes. And coming up in one of the future videos here in this section, I am actually going to have a video on how do you find the area of octagons and hexagons and things like that. There is actually a way to do that. It involves triangles, and we will talk about those shapes, because once you get into hexagonal prisms and pentagonal prisms and nonagonal prisms, things like that, you're going to need to know how to find areas of those shapes, which is possible, and I will be having a video on that in this section, so look forward to that. But that's all I got for you on why the volume formula works. In the next video, we're going to be showing you how it works. I'm going to be doing some examples where we find the volume of cylinders and prisms, so that you can actually get some examples written down in your notes. Also, before this video ends, please make sure you took notes. Okay, if you're in my class, make sure you wrote down some notes. If you did not, go back and take some notes, please. Thank you.